In this video, we're going to look at a couple examples of using synthetic division in order to find solutions or find zeros. So a couple things we can do with synthetic division is we can evaluate functions using the remainder theorem. We can also find zeros of functions. In other words, if you put a factor in and run it through synthetic division, if you get a zero out on the end, then it's considered to be a zero of that function. Okay, so in other words, if your remainder is a zero, then you have a zero to your function. So we're going to look at a couple examples so that you can see how to use synthetic division to kind of solve these polynomial problems. So here we have a polynomial, and here we want to know what f of 3 is. Now, algebra would dictate that we simply take the 3, plug it in for all our values of x, spit out an answer, and we'd be done. But we want to go ahead and use synthetic division in order to see what happens. So we're going to set up our synthetic division like normal. So you're going to draw a partial box, and here we're going to put our factor 3 into it. And then we're going to use our coefficients. So here we've got 1, -6, 11, -6. Now notice all of my terms in descending order have been represented. None of them are missing, and so we're good to go. Now we're going to set it up by drawing that initial arrow and our solution bar. So here we go. We drop the first one down, and now we get started. You take the bottom times the factor and put it under the next one. 1 times 3 is 3. We are then going to add these together vertically. -6 plus 3 is a -3. Bottom times the factor goes underneath the next. So this becomes -9. We are going to add these vertically. 11 plus -9 gives me a 2. Bottom times the factor goes under the next. 3 and 2 is 6. We're going to add these together, and we get 0. This is your remainder. Now, because that's a 0, what that means is that, first of all, f of 3 equals 0, and x equaling 3 is a 0 of the polynomial. This particularly, wanting to know what it was when we plugged it in, is the answer. However, we need to keep in mind, because this was a 0, it means we actually found a 0 of that polynomial function. It means we found an x-intercept point. Okay. Now here we've got another one, and the reason we're going to use synthetic division is because, 1, this is an imaginary, and 2, I don't have all of my x terms, so sometimes synthetic division can be considered a shortcut when evaluating. So here I have x to the 5th, so 1, but then I don't have any other x terms, so they have to be represented by 0. So I have 0x to the 4th, 0x to the 3rd, 0x squared, a 0x, and 32. So here I'm going to go ahead and drop it down, draw our solution bar, and we're going to go ahead and, just like before, get started. Bottom times the factor goes underneath. So this is going to be -3i. We are going to add these together, and this gives you -3i. Then we have to do it again. And so here it's sometimes a good idea to kind of run your multiplication off to the side if you need. Remember, here we're doing -3i times -3i. So this is going to be 9i squared, which is going to give me a -9. Okay, so keep in mind you have to use your complex imaginary number rules when working these problems out. So here this becomes negative 9. We are going to add these together, gives us a negative 9. Then we're going to multiply again. Bottom times the factor goes underneath. Negative and negative is positive, so this becomes 27i. We're going to add these together, and it gives us 27i underneath. 27i times the negative 3i is going to give us 81. We're going to add these together, and this is 81. Again, bottom times the factor goes underneath. This is going to give me negative 243i. We're going to add these together, and this gives us 32 minus 243i. So when we look at this, the evaluation, what we have is that f of negative 3i is going to give us 32 minus 243i. So there we have two examples, different examples, of using synthetic division in order to solve or work with evaluating polynomial functions of higher degrees. Oh, excuse me. So, on that squeaky note, if you have any questions, please let me know. Otherwise, I hope you enjoyed yourself and got a chuckle at my sneeze, and I look forward to seeing you next time.